So I'm just going to talk y'all through some of this information on section 6.6. We've gone over it in some of the classes, but I do want to go over one more thing with you about this. So if you'll notice here that we want to solve this equation, which means we want to find out what x equals. So I started off by factoring out the cosine x. Once I've done that, I'm left with this. So if you remember back to solving equations, once I have a product of something set equal to 0, I can set each of the pieces equal to 0. So then I know that cosine x is 0. I know that sine squared x is 1/2. And then if I square root both sides and then rationalize, I know that sine of x is the positive and negative square root of 2 over 2. So then the next question you have to ask yourself is, where is cosine x equal to 0? And cosine x is equal to 0 at pi over 2 and 3 pi over 2. And where is sine x equal to plus and minus square root of 2 over 2? It's equal to plus and minus at these locations. So what we found out is that these are the solutions to our problem. So we have actually 6 solutions to the problem. Okay? Now you can use your graphing calculator to graph the original equation and to graph these curves or to graph these points and see whether they are all valid points. You do have to check. If you don't use your graphing calculator and the graphing option, you will have to check each of these values and plug them in for x and see if they work. So I would recommend you use your graphing calculator to do that and just go to y equals. Okay. The second problem is a little bit more involved. So with this one, we again need 0, but if I move the 1 over, I'm not going to be able to do much with that. So for this one, I separated the two pieces. I've moved the cosine to the other side. I squared both sides. Remember, I can do something to both sides of the equation. We're not talking about identities. So sine squared can be rewritten as 1 minus cosine squared. And 1 minus cosine squared is FOILed out, and I get this. So now when I combine like terms, I end up with this expression. So now the reason I did all this is because I wanted only one term. I only wanted cosine, and now I can factor out my cosine, and I'm left with 1 minus cosine x. So now I can set each piece equal to 0, just like I did up above. And where's cosine equal to 0? At pi over 2 and 3 pi over 2. Where is cosine equal to 1? Cosine is equal to 1 at 0, okay? And it's also equal to 1 at 2 pi. But 2 pi, if we look up here in our problem, is not included. It's just less than 2 pi. So we don't include the 2 pi. So the thing that's interesting about this problem is that when I do test it, when I put in pi over 2 for sine and pi over 2 for cosine, going back to the original problem, I end up with 1 equals 1. So pi over 2 works. But if I test 3 pi over 2, sine of 3 pi over 2 is negative 1, and cosine of 3 pi over 2 is 0, so I end up with negative 1 equals negative 1. That's not a solution. Because I need it to be 1 equals 1. Okay? So the third option is sine of 0 and cosine of 0. So sine of 0 is 0. Cosine of 0 is 1. So 1 equals 1. So this one does work. So when you actually graph it, you'll see that the 3 pi over 2 actually does not work for this problem. Only the pi over 2 and the 0 work. So if you look at this example, so I put it on my graphing calculator. So I put it in, notice how I put in -1 instead of the equals 1. It makes it a little bit easier to see. For my mode, I make sure I'm in radian mode. For my window, I set it at 0 to 2 pi, and I scaled it at pi over 2 since that was one of my answers. And then the X-min and X-max, it's nice to have it at 3, just because it shows us a clear picture. And when you graph this, I know you can't see it great, but when you graph it, you'll notice that at my tick marks, here's my tick mark pi over 2, 2 pi over 2, 3 pi over 2, you'll notice that the only zeros are at 0 and pi over 2. 3 pi over 2 did not work. So this is a really good way to check. Instead of having to plug in all the values, you can check it using this method. Okay? All right, the problem on the back, let's look at the first one. It's a little bit more complicated. So if you'll notice here, I rewrote this problem as a quadratic problem. And I would try and factor it. 4 times 3 is 12, but there are no multiples of 12 that give me 5. So I have to do quadratic formula. Okay, and when I do quadratic formula and I plug this in, I get approximately 2.26 and negative 0.59. So to figure out the angles, I would recommend, I've got it in radian mode here, but I would recommend maybe degree mode to check it. So if you put in cosine inverse 2.26, it comes out to be an error message. It's undefined. Because remember that for inverses, this value has to be between 1 and -1. Cosine -1, 0.59, equals 2.20, which is in radians, pi is 3.14, so this would be a number in quadrant 2. So if I wanted to figure out other solutions, I could add 2 pi to it, and I could find, or subtract 2 pi from it, and I'll find out another solution, or I could add 180 to it. I could add 90 to it and figure out another solution. So that's one way of doing that one. All right. Our next one, notice that you have sine 3x equals 1. So what you're going to do is treat this a little bit differently. You're going to ask yourself, where is sine 1? Don't worry about the 3x yet. Sine is 1 at pi over 2. So that means that 3x has to equal pi over 2. But there's no, I'm not telling you up here to only give me answers like I did back here. Back here I said only give me the answers between 0 and 2 pi. I'm not restricting you here. So that means I want every single possible solution for this problem. So if pi over 2 is a solution, that means that if I go around the unit circle one time, I'm at another solution. And if I do that again, I'll keep finding more solutions. So I add 2k times pi. K is 0, my answer is pi over 2. K is 1, it's pi over 2 plus 2 pi. And I could keep doing that. So my next step is to get rid of that 3, so I have to divide everything by 3, which gives me this. So these are all of my solutions to this problem. So if I pick any value from this list, it'll give me a solution to this problem. Okay, our last one. So you'll notice for this one that I've got the 2 x's in there and a whole bunch of other stuff that looks a little bit confusing. So if I rewrite this as a quadratic, or if I rewrite it using different variables, basically I have u squared here. Since all of these are 2 x's, sine 2x, sine 2x, sine 2x, I have a u squared here. I have a square root of 3 over 2u here. I have a 1u here. I have a square root of 3 over 2 with no u. So basically what I'm saying is that u equals sine of 2x. So now I can group and factor. So I grouped it and factored here. I grouped this and factored here. And now I factor those two using grouping. And I can set each of these equal to 0, so I end up with, if you wanted to think of it, I sort of left out a step. You basically have one step here where u is equal to -1 and u is equal to square root of 3 over 2. So then I go back and I replace this u with the sign of 2x. And that's how I came up with this statement and this statement. So now we treat it just like we did the problem up at the top. And I need to know where is sine -1. Okay, and sine is -1 at 270. So, and then I need to add 360 to it. So I did the same thing I did above, but notice here instead of doing 0 to 2 pi, it's 0 to 360. So that's why we did 270 instead. And I also want to know where is sine square root of 3 over 2. Sine is square root of 3 over 2 at 60. So I add the 360k. And these are my solutions to the problem. So I end up with all of these possible solutions to the problem in order to get the answers between 0 and 360. So I hope this helps. And you've got exam review for the test that you have next week. So this should help with that. And you can review this if you were in class. Maybe it'll still help you to understand it better.